Okay, welcome to lecture 4 of the Unix systems course. Um, we are now, here, let me change the view. We're now going to discuss bash programming more, or we're going to start really and see how far we get. Shell programming in bash. So some of this is already things that you know at the beginning here. Just make sure we cover all the ground. Any command that works in the shell, like cd or ls, can be put into a file. When you run that file, the command will run. For example, ls, you could just put it in a file with nothing else in the file, just the word ls, and then run the file. The shell will run it. You can put many commands in a file, one after the other on separate lines. Running that file will run all the commands one after the other. Now, the default is to run the commands using the current shell, which in your case would probably be bash, but it could be anything. But you can specify the desired shell to run the command by typing this shebang line, like we saw with awk. Comment exclamation mark, and then remember the comment tells it that, from the language point of view, it's a comment, but it's telling the shell, oh, this is what I want you to run this command, this file with. So the first line of your file could be bin bash, and then it will try to run the commands using the interpreter bin bash, or bash, which is located in bin. And bin bash is the shell you want to run. Okay. Let's start with some simple examples. It's kind of a weird for loop, but it's really like a for each if you know other languages. In this example, variable I will be assigned 3 variables in succession. In other words, actually, I'm going to change that. That's a mistake. In this example, variable I will be assigned 3 values. View in succession. When loop runs out of data, it will end. So the values that I'm giving I are the characters A and B and C. That's 3 values. So what happens is I'm doing for I in, this is a for I in loop. For I in ABC, do echo I, $I, because we remember we define it, we assign it here, the values. It's going to be assigned 3 successive values, but not simultaneously, one after the other. And then we echo the $I, done indicates the end of our loop. So this will print ABC. You could add comments with the pound symbol. For example, pound referred to variable I as $I. When you declare variables, you need to define them. Do this using the equals with no spaces. Very important, no spaces. Example, my variable equals hello. No need to quote strings. For space, you can enclose you can quote your strings. You can enclose in quotes, or you can escape the space character with a backslash. Okay, so that's if you want to have a space. In other words, you could write my variable equals hello, and then you could write backslash space world. And then my variable would have the value hello world. Or you could put hello world in quotes. Either way. Further use of variables requires prepending the $sign. So for example, if I have my variable already defined as hello, and I want I to be equal to my variable, then I'd write I equals $ my variable. Any questions so far? Okay, here I will run a command and use the output as my list of items to iterate upon. So for example, here's my actual program. A equals nothing. It's a string. For I in list, now here we talked about this a little bit. This is a backtick, and it means run the command ls my directory. And then whatever the output of that command is will be assigned sequentially to I. In other words, every individual space delimited or return or white space delineated result will be assigned to I in succession. So if my directory has in it 3 files, then presumably 3 files will be assigned to I. So in my example, I had a directory called clum1, clum2, and clum3, 3 directories. But I printed out $A, $I. So $A is nothing, and $I is whatever the result, which is clum1 or clum2 or clum3. So I'm going to get nothing clum1 for the first one, nothing clum2, nothing clum3. That's my output.
I'm wondering what exactly are we interacting with, or what can we interact with? This is file names, and we're changing. Like, are we theoretically changing file names? Are we changing the contents of files, or can we do both?
We're starting off very simple here. We're just printing strings at the moment. We're creating strings to print based on file names. That's what this program does. But it's just a demonstration of what you can do with the for in. We'll get to more complicated things, I hope. Exit. Use exit to end the script before the end. In other words, if here, what do I do here? The same program, my directory, but now I just exit. So it's only going to print, I exit right there, is going to end the program, and therefore it's only going to print nothing clum1, not the other 2, because the loop left off in the middle. This is not a break. This is an exit. It ends the whole program. Okay. Defining a range of variables in a for loop. So this is a more like a loop that you are used to from C++ or from Java or from many other languages. So what we do is say for I in, and we use this as a range symbol here. The range 0 to 10. Do welcome I times. So it'll print and then done. So the default incrementation is 1. So it's going to print hello, welcome 0 times. It's going to print welcome 0 times. Then it's going to print welcome 1 times, welcome 2 times, until it gets to 10, and it'll print welcome 10 times. And then the loop will finish. So this is a range. Well, that's kind of like a for loop. I'm just printing here hello. I could obviously add the numbers up also. But you can specify a different number. In other words, the incrementation is normally 1, but if I do like this, 0 to 10, ... 2, so that means count by 2s. So now it'll print welcome 0 times, welcome 2 times, welcome 4 times, until it gets to welcome 10 times. Okay. What about using tests with if? So not equal, we saw this before, actually, I think. Not equal for strings is the exclamation mark followed by an equals. That's not equals for strings. And equals is a single equal sign. But with spaces, you see. That's why the assignment with equals is without spaces. This is with spaces. So spaces before and after the first bracket are required. So notice, okay, spaces before and after the exclamation mark, spaces before and no, I guess here's another mistake. Okay, so space before no, I did that wrong. That was dumb. Sorry. Now it's right. Just like I have an example. Space before the bracket and after the semicolon is also required. So for I in, and again, my same command. So it should be clum1, clum2, and clum3. Now I say if I, notice the spaces after the if and after the first bracket required. If I, $I, which is whatever I got over here, is not equal to clum1, then echo I. So it's going to print clum2 and clum3. Which is what it does here. So that's using an if. More testing tools. Or I can do if I is clum1 minus O, or I is clum2, then echo it. Otherwise, echo ABC followed by the number. So it's going to print clum1, clum2, and then on the third line, it's going to print ABC, clum3. And here is like a copy of some of the parts of the manual page for the word test, the command test. And you see the or and the minus A is and you see equals for strings, but minus EQ for integers. Kind of funny because when you talk about integers, you have to use the string version of the equals. And when you're using the strings, you have to use the mathematics kind of equals. Kind of weird, but that's the way they did it. So equals greater than or equal to, less than, GT is greater than, LT is less than, and LE is less than or equal to. And this is just the meaning of each of these commands. And I have more. These are file commands. Minus K on the file name means minus K. The file exists and has its sticky bit set. Well, we didn't learn about that yet, but okay. Two file testing examples. So now that we understood that we can also test files, I can do for I in ls, that's going to be all the files in the directory, do if minus D on the file, if the file is a directory, that's what minus D means, then echo the file name. So I'm going to just print those file names that are actually not files, but directories. If I do this example, minus R, not, notice I wrote the not here in front, not, if not readable, if the directory, if, notice what I did here. I wrote directory $I. Why did I do that? Because when I did ls my directory, I got the things that not in my local, not like this ls where I got the things in the current directory. Here I got the files that are not in the current directory, but in the directory beneath inside of my directory. So if I would try to check for the existence of just $I, it wouldn't be there because it's not, I didn't ask for things that are in the current directory. I asked for things that are in the lower down directory called my directory. So I need to prepend my directory to the file name so that it knows where to go to find that file. And so I say, if it's that file is in fact readable, then print just the name of the file. Now there's some special variables. Up till now we had variables like, with letter names, but there's also special variables with other special ones, numbers and other things. So if I would just over here print, echo $0, what would I get? So $0 is the program name. In other words, when I run the program, I type the program name. I say, if my program is called my program, then I'm going to type my program, enter. So the program name is whatever I typed as the name. But the program could also be written, some programs could have parameters, which means I don't just write my name, enter. I write my name, my program, space, parameter 1, parameter 2, parameter 3. Like I could write my program space 1, space 2, space 3, and then enter. So the parameters are whatever is received on the command line when I ran the program. So if I do echo $1, it'll be the first parameter, $2, the second parameter, and so on. Echo $3, $4, all the parameters that I got. What if I want to know how many total parameters there were? Because maybe he ran the program like this, my script 1, 2, 3, 4. Maybe he ran it my script 1, 2, 3. I want to know. So I can print $sign. That tells me how many parameters. If I want the entire parameter list, I can print $, and then it'll give me 1, 2, 3, 4. And if I want the process number of the script that I'm running, because remember, whenever I run my script here, when I hit my script 1, 2, 3, 4, enter, my script turns into a process and it's running. And every process has a process ID called the PID. If I want to print that number for some reason, I can by doing echo $. So there you see a bunch of special variables that are like predefined. Okay. Sample use. So I could say, like, here's a while loop and a test. Because remember, a while loop is going to have like an if, like an if has. You know, it's going to have a test, like an if. Not a for. See, the for had sort of a basic ending because it was whatever items that are in it. Or I gave it a range. Give it a range of numbers. This actually generates 0, 1, 2, 3, 4, 5, 6. It generates this as though I wrote 1, 2, 3, 4, 5. This command is like a shell command to generate those numbers. I could use it outside of a bash program in the command line, for example. So this is a normal for loop, has like a limit built into it by how many elements there are. But when I do a while loop, I need to have a condition. So as long as the number of arguments is not 0, do. Make sure not 0 arguments. But now what do? Is I echo, here I gave it the complete path of echo. I didn't have to do that. I could have just written echo. -n means do not output the trailing new line. In other words, don't give me a new line. And then I echoed $, $pound, or $sign, which will tell me how many arguments there were. If you type 1, 2, 3, 4, it'll tell me 4. Then I echo the first parameter, which is 1. Then there's this funny command called shift. And what shift does is it shifts off one argument. It sort of pushes one of the arguments off the edge of a cliff and it disappears. So that means that there's now no longer argument 1. I pushed it off a cliff. There's only argument 2, 3, and 4. But what happens is 2 becomes argument 1, and 3 becomes argument 2, and 4 becomes argument 3. Because it's like I pushed it off, so now the list of arguments has gotten smaller. So if I check how many arguments do I have, it's going to be 3, not 4. But 3 is also not equal to 0, so it's going to print $, pound, and then it's going to print the first argument. It's going to print 2, because 2 is now the first argument because I pushed off 1. Assuming I ran the program like this, 1, 2, 3, 4. So I pushed off 1, and now this is the first argument, and there are 3 arguments, 2, 3, and 4. And then I do another shift. So now I pushed off the 2, and I just have 3, 4. But 3, 4 is not 0, so it's going to print again a $pound symbol. Then it's going to print argument 1, which is now, since I pushed off 2, I pushed off 1 and 2, it's going to be now 3. It'll be argument 1. You see, I'm shifting them off and printing them one by one. So I'm going to print on separate lines arguments 1, 2, 3, and 4. At this point, print $1 would result in a blank line. If I kept doing, or if I did another echo $1 after the whole loop finished, everyone sees that the argument number is going to go down to 0. And therefore this loop, as long as it's not equal to 0, it's going to be, as long as it's going to reach 0 at some point, and then it's going to end. So I'm basically shifting off each argument as I come to it and printing it out and then shifting it off. And then the new level of arguments is going to get smaller until it gets to 0, then it's going to stop the loop. Now, if I would try to print $1 after this done, it would just print. That's interesting. Right, if I print $1 at this point, it would result in a blank line because there is no argument 1 anymore. I've shifted it off. I got all the way to the end and then I shifted it off. All right, wait, let's let me take another break. Are there any questions right now?
Not right now.
All right. Okay. Input, output in bash, built-in commands. We saw that you can create output with the echo command. Bash has another built-in command for doing output called printf, which you might know from C programming. But printf doesn't have parentheses like a C function. More on built-in commands in bash can be found at this website. Okay, Computer Hope. Printf is more versatile than echo. It allows you to format the printing. Now, I'm also going to show you how to read a line, so C in and C out, input and output. To read a single line from the standard input, use the built-in shell command called read. So you have read A, which means it's going to wait for somebody to type something. Whatever they type will go in a variable called A. And then print $A. It'll print it. Example 2 is read A, and then printf. You typed %s. Now %s means percent just means I'm going to give you like a reference to a variable, and I'm going to tell you to print it as a string, because I could print it as a decimal number or as a string or as a character, but I'm going to tell you print it as a string. Expect to be a string, and then \n means new line. So you typed, and then when I write $A here, that's the string that you typed. It's going to assign this $A to the location where the %s is. So I could have multiple variables, and I could put them. I could intersperse them throughout my string, and it'll go by the order of the variables that are written here. The first one goes to the first %s. The second variable, if there would go to the next %s. There has to be a %s for each string I want to print. You could also do %d for decimal numbers. Read example. So we can do while read, do echo. I did this in one line. While read, do echo $reply done. Now this is a little bit weird. Notice that my read did not have a variable here. And what is this $reply? Notice that it's capital, which indicates that it's something special. So this is read and print in a loop. Because no variable was specified at the read, the entire line of text is stored in the special variable called reply, built-in variable. This loop continues until you press Control-D, which is, not as a plus, it should be a minus really. Control-D, which is the end of file indicator. for a new line. So this loop will continue reading until read gets something which is nothing. What's nothing? End of file. Equivalent to the above command would be while read text, do echo text. I'm done. You see, I'm just I didn't have to, since I may often want to do something like this, I may often want to read something and then I don't care what the variable name is. I just want to use it. So we have this built-in variable for reply called reply. You can also read directly into an array. We will learn about arrays in Bash later in this presentation. And then print each element in the loop, in a loop. So I can do like this. -a means array. So read my array. And then what that's going to do is if he types in hello world, it'll take hello and world as two separate elements in the array. For I in, now this is a special way of writing, meaning the whole array for all the elements in the, this grabs me all the elements of the array, and it does a for in loop. So I'm going to go through each one of them. Notice I write the ampersand here. Now there's not a particular element of the array, but the whole array. That's what that ampersand means. Do echo I, $I. So that's the variable here. So it's going to print me all the elements in the array, but on a new line, each one. Questions? Okay, delineating variable. Now, this is an important thing also. If you print, for example, hello var Danzig, you'll have no problem. It'll be hello Mr. Danzig. But what if the variable is adjacent? I want to have Mr. Danzig as one string. Well, I want to do like this, hello Mr. Danzig. Will this work? The answer is no, it will not work. Because it will, can anyone tell me why it won't work? What will it think?
I think that it's a variable var Danzig instead of just plain var.
It'll think it's a variable var Danzig, and there is no and it'll print like blank, because that variable is not defined, so it'll print just the empty string. So you need to use the braces to delineate your variable. So I write it like this, hello, and then I delineate that the variable ends after this R. So then hello var Danzig. So it'll print hello Mr. Danzig, like that. Specifying elements in a range. We saw previously that we can specify a range using braces. Remember we did that like this. You can also use the braces to specify elements in a range in general. In other words, I can just write echo, that same thing that I did with the for in, I can just do 1 to 10, and it'll print echo this range, 1, 2, 3, it'll print all the numbers. Now, this is just a shorthand way of writing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or I can do echo WER. Well, that's not really a range, but it's those elements. It will print W and E and R. Practical example. I don't know how practical this is, but here's a practical example. Hello, echo hello AB. So it means not really a range, but it's individual items. As this is a range, this is elements. So the elements A and B. So hello AB. We'll print hello A and hello B. Because it's as though I appended to hello one time A and one time I appended B. So it prints both of them. Echo $1. What's $1? Anyone remember what $1 would be? Would be the first parameter when I ran the function. So echo $1, which in this case I'm assuming is, let's say, the word go. And then comma 1, 2, 3. What does that mean? So the first element is the blank element. So it'll print go without anything after it. There was blank after it. So if $1 is go, then it'll print go, and then go 1, and then go 2, and then go 3. I can even have a blank element in my list of elements. All right, now we're going to talk about the special environment variables. We mentioned this. We talked about path before, I think. And we can also, there's a special variables called, they're environment variables. It means they're defined by the session. Special variables defined by each user's login scripts. When you log into your terminal, so it'll define these variables for you, and then you don't behind the scenes, you don't even see it, and then you can use them. There's no limit as to how many are created at the login time, but by convention they're all capitalized. And these are some examples of ones that are usually created. Your home directory is in a variable called $home. Your path is in a variable called $path, and your user name is in a variable called user. So if I did echo of each one of them, I would get my home directory, my path, and my username. Now we have an interesting example of defining and undefining a variable. It's kind of funny. You don't have this in C or C++ or Java, but you have a variable that exists but is not defined. It's very weird. What does it mean? But we don't think it means that it has no value. It's not been given a value. In C++, that would be a compile error. But here it's not a compile error. Well, there's no compiling. But echo $x. So $x, if this is the whole program, $x has not been defined. So it'll print a blank line because X is undefined. Then I can do like this, some special things. Once I've learned that I have these delimiters for the variable name, I can do special things inside them. And I can say, I can do like an if thing. If X is undefined, then A. In other words, print X, but if it's undefined, then don't bother printing it. Print a different variable, print A. And the way I write that is with a colon and a minus A. Now, if I print again X, it'll get a blank line because X is still undefined. But if I, instead of doing a minus sign, I do an equal sign, then if X is undefined, define it as A. Now X becomes A, the value A. So I won't just print A like I did here. I'll actually define X as A and then print X. So it'll print, this line will print an A. But now this line will also print an A because I actually defined X. Now, if I had minus means if it's undefined, then plus means if it is defined. So if X is defined, then print B. So it'll print B because X is defined. Now, if I want to undefine X again, I can write X equals and not write anything. That undefines it. So now I can say if X is defined, print B. But X is not defined, so it won't print B, it'll print X. But X is undefined, so it'll print a blank line. Now, if I define X is equal to apple, so now X is not 1 letter long, but it's like it was at some point. It's 5 letters long. So echo X colon. Now there's no plus or equals or minus. There's just a number, 1 colon 2. So it'll print from index 1, 2 more characters. It'll print 2 characters from index 1. It's not a range exactly. I mean, it is a range. It's 2. It's not 1 to 2 though. It's not like the beginning and the end of the array. It's starting at 1. How many should I print? So it's going to print 0 is A, so 1 is the P. So it'll print P, P. This is okay. Now, if I create 2 variables where the value of one variable happens to be the name of some other variable, I can use that value as a variable name. This is called indirection. This is a little bit complicated. What this means is like this. It's like a kind of like a pointer, but let's see. X equals apple. Fine, fair enough. Now apple, the variable apple equals pear. So if I print echo $X, so it's going to print X equals apple. So it's going to print apple. So obviously, what else would it print? But if I do not regular X, but X with an exclamation mark in front of it, then that means view X as a pointer. Use indirection, which means use the value of X, which is apple, as we showed here, but view that apple as a variable name. So in other words, print the value of the variable name whose name is equal to the value of variable X. Variable X's value is apple, and there happens to be a variable called apple. So it's going to print the variable called apple. So it's going to print pear.
I have a silly question, but if we named apple, instead of pear, we named it exclamation mark pear, would it keep going?
I'm not sure that exclamation mark is a valid character for a variable name.
Oh, that makes sense. Okay.
I think that's the answer. In other words, you can't create a variable called exclamation mark pear. Just like in C++, there's limited things that you can use for variable names.
So we can't continue doing indirect, well, or maybe there's some other way.
Well, with multiple parentheses,
indirection.
you could. With multiple parentheses, you could. In other words, yeah, I think with multiple braces, you could. You want to make another variable called pear and give it a value and print that one via X. You might be able to do that with enough parentheses.
Yeah, I'll give pear the value X.
Well, don't get too confused. Just give pear the value peach, and then try to print peach via X. That might work. That's called indirection. I don't think you should get any more than one level of indirection, but I think you could. I mean, I don't think you should, but I think you could. I never tried it. Script to print all files containing the string fork. I think this is actually, I think, a target. That's something I assigned you in the lab. But so here we have for I in ls star. So that's going to give me I being the name of all the files in the system, in the directory. If minus F, if it's a regular file, I believe that's what minus F is. We can quickly check. Minus F, file exists and is a regular file. If the file is a regular file, that whatever I got in my ls, then if, now with these parentheses mean run this command. If grep q means quiet, which means don't give me any response if you find it, except give me the response true or false. So this parentheses will resolve as either true or false, because I did quiet here. Now, normally grep, as we saw, gives you the actual string that you're looking for. So I was saying, if I can successfully grep the word fork from inside the file that I got that's stored now in $1.
What's Q?
I just said quiet.
Oh.
Q is quiet. Don't give me the normal response. Just give me the true or false value. If you found fork in the file I, then echo the file name. But if the file, so this would check if the file has in it the word fork or not. And then phi closes my if, and this phi closes this if. We don't use parentheses, we use phi. And this done closes the for loop. The do closes the do really. Okay. Oh, that's it. That's it for lecture 4. Stop share.